Hi, everyone, and welcome to the session. My name is Dennis Tremor, and I'm the Director of Sustainability at Pulse Canada. Just a quick background on myself. I've been working at Pulse Canada for 10 years, always in this area of environmental science and agriculture. My role is really focused on the benefits of pulses within food systems and how we can use them within food systems themselves. My academic background is actually in environmental science and agriculture as well. I have a master's degree in soil science with kind of a focus on greenhouse gas emissions. And I've always appreciated the benefit that pulses can bring to our cropping systems in Canada. But now this discussion is really focused more on how can pulses really help foods and help people when it comes to their choices and how they can make impacts on sustainability. So today we're kicking off our three-part mini webinar series talking about the sustainability of pulses. But before we begin, I want to go over a couple of housekeeping items. We'll be recording today's session and circulating the recording with all registrants afterwards by email. We've reserved a few minutes at the end of the presentation for questions, and you can submit your questions at any time by using the Q&A box in your control panel to type them in. So it could be at the top of your screen. If you're having any technical difficulties, feel free to use the chat box to send us a message. So with that, we'll get started. Just as a quick introduction, Pulse Canada is the national association representing growers, traders, and processors of Canadian pulses. We help companies capitalize on pulse ingredients while facilitating research within the health, sustainability, and applications of pulses. So we're known kind of as a technical hub for pulses internationally. We've got expertise at Pulse Canada that focuses on sustainability, like myself. And also we have experts in the aspects of nutrition and health, regulatory attributes of different countries and how pulses fit within them, and also the functional attributes of pulses and how can they fit within food products like bakery or snacks or even meat applications. When we're talking about this topic today in terms of the environment and also on health, there's been a real groundswell of interest academically from the research community and from the food industry on the impacts that diet has on health and the environment. Governments have been getting involved in this type of discussion as well with food guides, but the Eat Lancet report in 2019 is a really good example of a group of people, of international academics and experts that really focused on what are the impacts of food on the planet and the health. And this statement really kind of nails it on the head, because it's pretty obvious that food has an impact on health with the issues we have globally around obesity and diabetes and other diseases associated with foods, but also we have a lack of nutrition in some areas of the world as well. And but the other piece that's become really apparent is that food has an impact on our planetary boundaries as well, and the environment. So I'll speak a bit more to that. If we look at food systems and agricultural systems around the world, you'll see that it actually forms the major component for some environmental indicators. Things like land use. If you look at a satellite image of any part of the world, you'll see that agriculture really swallows a lot of the habitable land that we have. And the rest, there's a real priority to try to keep the amount of forest and natural habitat we have left as natural habitat, because there's ecosystem services that are provided for fresh water, clean fresh water, and even things like the climate that those landscapes provide. Water, there is no larger consumer of water in the world than agriculture, and most of that is actually tied with withdrawals of water from groundwater or from surface water like lakes for irrigation. Irrigation globally has a huge amount of consumption of water. It represents most of it in the world. And then also another component is things like eutrophication, which would be what we see as like algae blooms in the oceans and the lakes. Most of that can be attributed to agricultural systems where we have runoff of nutrients from our fertilizers and other things that we use in agriculture. But the other last component that's important that people are talking about a lot these days is greenhouse gas emissions, and food production represents about 26% of those global emissions. So it's not a not substantial amount, obviously. And when we talk about greenhouse gases specifically, but for most of these other impacts as well, we have to really talk about production as having the greatest impact. Whether it's livestock or crop production, or land use change that we have from converting forest land to cropland and livestock production, that really has the major impact. People want to talk a lot about transportation and local versus imported products. We want to talk about packaging, and those things are important components. But really, at the end of the day, if you don't get the production systems right, and if we don't reduce emissions within our production systems themselves, then we're not going to be able to achieve our goals around sustainability. And especially for greenhouse gas emissions, it's the goals of trying to achieve below 2% or 1.5, below 2 degrees or 1.5 degrees of warming globally around the world. So food is essential. If we don't get it right, we can't reach these goals globally, regardless of what we do around transportation and electricity production. And this has been linked with consumers as well. Consumers are getting this as well. We're seeing more and more, or we're seeing more interest from consumers. The question now is, how is that translating into actual buying behavior? But we saw a big distraction, obviously, with COVID. But the COP 2020 discussion has kind of continued that focus and actually increased the focus of linking climate and other environmental impacts with agriculture and food production. So this is still ongoing, and it's not going away anytime soon. So now shifting to Canadian pulses, and the impacts that they have within our systems, but also the significant benefits they can have to food systems as a whole. I just wanted to speak first to the fact that Canadian production of pulses is big. We're the second largest producer in the world after India. And it's been growing over time. We've been able to tap into international markets, and also our domestic markets are growing with things like processing of peas into proteins and other ingredients. So we've got good demand globally for pulses, and we've been able to tap into that, especially for crops like peas and lentils, but we're also a substantial producer of crops like dry beans and chickpeas. But those peas and lentils are really the big component of our production, and they're mostly grown in Western Canada. And I'll speak a bit more to that later. So the benefits of that Canadian pulse production, first of all, I just want to say we grow most of these pulses in Western Canada. And in Western Canada, in the provinces of Alberta and Saskatchewan, and somewhat in Manitoba, a lot of our growers aren't tilling soil anymore. So we've parked our tillage equipment as farmers, and we conduct no-till or minimal till production systems. And that's really helped prevent carbon loss. It's helped prevent soil erosion. It's helped build soil organic matter and really increase the amount of moisture we have in our soils, which all points to improved sustainability of our crop production systems, improved productivity, and somewhat less requirement for inputs. And pulses really fit into that system well. So I was just in Western Canada, especially in Saskatchewan and Alberta, we have a semi-arid climate where moisture stress and lack of rainfall, it really is one of our big risks. And we saw that last year with a major drought in Western Canada. So how pulses fitted within that system is researchers and farmers realized that we needed crops that relied less so on that required less water and left more in the soil for the following crop. Something that was better adapted to our semi-arid climate and helped improve the sustainability of that rotation as we're rotating crops like wheat and canola and other crops with pulses. So pulses are water efficient, they leave more water for the following crop, and they help increase yields for crops that are grown afterwards. Another component here is that a very small percentage of our pulses are irrigated. They're suited for these dry climates, so we don't need to irrigate them, and we don't have the water in most parts of the prairies to use for this purpose. These good crop rotations with pulses are more common in in the prairies and in Canada than most places in the world. And they help boost the soil health of our systems by boosting the soil microbial diversity. And that's really attributed to the straw and the crop residues that pulses leave behind, which help feed the soil components and that aren't there with other crops. And that really helps the health of the soil, and it really benefits the following crop in rotation. So what we see often, and there's tons of research on this, is that wheat grown after pulses has higher protein, it grows better, and that has to do with better nutrition and a better soil microbial profile that helps reduce disease as well. Another component that's talked about a lot these days in sustainability circles in agriculture and food is regenerative agriculture. And I wanted to just talk about the alignment of the principles of regenerative agriculture with the crop production systems we have, especially where we grow a lot of these crop pulses like peas and lentils in Canada. So the first two principles of regenerative agriculture are reduce tillage and keep the soil covered. And like I mentioned earlier, the majority of our producers are practicing no-till or reduced tillage, and that really creates a landscape like we see to the right in the picture, where we have a crop of peas that's emerging out of a field that wasn't tilled. All that straw from the previous crop is remaining on the surface. It's protecting the soil from the sun, it's protecting the soil from precipitation, and it's preventing erosion as well. The pulses within that system that are growing now really help maximize crop diversity. And that's something that farmers have really well employed in Canada, is diversifying that crop rotation as much as they can and when they can, based on economics, but also based on markets and what grows well in the system. And that really reflects that fourth principle, that farmers understood the context of their system. What are the environmental risks? What are the crop production risks? How can they adapt that system as well? And the last two components are a little harder for a lot of farmers to implement, especially on the prairies. Living roots is something that's challenging. Living roots all year long in our systems can be challenging with the winters. It's -27 as I speak right now outside. We don't have a lot of things growing right now in the field, but there are cover crops that we can put in the field that would survive a winter like this. So there's more research going on in this area, but we do have some limitations of what we can do. And then integrating livestock with cropping systems. Some farmers do this if they have livestock as part of their production system. They have cattle or dairy, and in some cases they'll have neighbors with cattle, and they help each other with land and integrating each other's systems. But obviously that is in the context of where you live and who's around you and what do you have around you. So the next piece here that I want to talk about I spoke about earlier about crop residues and pulses and how they help feed the soil. And a lot of that component that what we're talking about is nitrogen. And for as long as we've had farming, we've had a problem with nitrogen, where most of the nitrogen is in the air in a form that's not available for plants as atmospheric nitrogen. It's the most limiting nutrient we have in our systems, where we need large quantities of nitrogen to be able to produce the food that we need to feed the world. It costs a lot of energy to produce to produce nitrogen. So we have nitrogen fertilizer plants around the world that consume a lot of natural gas, and that equates to about 2 to 3% of global greenhouse gas emissions. And then finally, when we apply nitrogen to the soil through synthetic fertilizers or other forms of nitrogen like manure, we get environmental losses. So we can get leaching and runoff that can pollute water bodies, which can be limited in some cases as long as farmers put on the right amount. But one thing that we can't really get away from is losing nitrogen to the atmosphere as gaseous nitrogen, and in particular nitrous oxide. And that in crop production, that is the most important greenhouse gas that we need to consider, more so than carbon dioxide and others. So, and I'll speak to that here a little bit. When we look at global emissions of greenhouse gas emissions, we really need to focus on carbon dioxide. And that being because most of our energy sources for transportation and electricity production come from fossil fuels that produce carbon dioxide, but also methane and nitrous oxide are components as well. And those sources are mostly from agriculture. So when we talk about agriculture, carbon dioxide is a little bit understated here in this graph to the right, because it's not including fuel use from tractors and other equipment. But methane from cattle and from manure application systems and nitrous oxide from crop production soils are really the components that we need to tackle in agriculture. And just going to the next slide here, pulses really help challenge or help reduce the amount of emissions we have for nitrous oxide. And that's because they are fixing nitrogen from the air naturally through a biological process where they have a symbiotic relationship with soil bacteria. They make a home for those bacteria in the roots through nodules, where they provide carbohydrates and a living environment for the bacteria. And the bacteria are fixing nitrogen from the air through a process that's as old as time. And they provide that nitrogen in a plant available form to the plant. So those pulses that are using this process get the majority of their nitrogen from this process for their growth and their reproduction and the production of yield. So it really has a major component. It really reduces the amount of emissions that we can get from a crop production system when we include pulses in rotation. So it's a major opportunity to reduce emissions from agriculture and food systems. And that really has an impact on the footprint of pulses compared to other food sources around the world, whether they be other foods like grains, but in particular, when we compare them to livestock products, they have almost a minuscule footprint compared to a lot of these other foods. It's important to note that there's variability within all of them, whether they're pulses or whether they're livestock products, there's lots of variability. So we'll see here that Canadian beef has about half the footprint of the global average. And that's actually the same case here for dairy production and for poultry and pork production as well. Canada has a system that is pretty efficient, and we've been able to reduce the emissions per unit of production compared to a lot of other jurisdictions. And when we dig in a little deeper within our crop production systems, we do also see that pulses have a much lower footprint than the alternative crops that we grow in rotation, like cereals, like wheat and barley and oats, but also canola. These crops require nitrogen fertilizer, some more than others, and that is the major contributor to them having a higher footprint compared to pulses like peas and lentils. And when we grow them, when we scale this up across the landscape, because we're growing so much pulses, it actually has a major impact on the amount of emissions we have in Canada from our agricultural systems. So this was a back of the napkin calculation that I had done, where I found out that it was about 1 million tons of CO2. But we actually have a report coming out focused on this that is actually will paint a better picture and a more comprehensive picture of what is the impact of Canadian pulses across the national landscape. And the last component here of pulses having a benefit is that we get to leverage the fact that our producers are employing practices like no-till, which are sequestering carbon into our soils. And for crops like lentils, the amount of carbon being sequestered in the ground actually is bigger than the amount of emissions that are associated with the production in the field of lentils. So the amount of fertilizers and fuel and inputs that we use produces emissions, but we're actually sequestering more carbon in our soils than those emissions. So effectively, lentils in Canada can be considered negative from a carbon balance perspective. What we've done is we've recognized that there's a need for a more comprehensive view and a better data set around sustainability. Most of the work that's been done in the past has been done by researchers that are making assumptions or collecting just the knowledge that they have in the field. But it's good to actually collect data from producers to be able to back that up. So what we did a couple of years ago was we collected data from almost 600 farmers across Western Canada that produced peas and lentils, or peas and lentils. And we captured all the input and crop production information that we required to conduct a life cycle assessment. So this has been published. We have the report available on our website as a summary report. We also have a more comprehensive report available upon request. And it's really is backing up the what we knew already. We've had lots of reports that have told us that the footprint of pulses like peas and lentils is quite low. But now we have that backed up with all of this farmer data that's been reviewed by our own experts across the prairies as well. So, and the last thing I would say is that we have also published the data in this from this study within life cycle inventories like EcoInvent, which allows food companies and ingredient companies to conduct their own assessment of their own ingredients that include pulses from Canada. So that's been made available in the form that companies, researchers, and consultants need to conduct those assessments. But this isn't the end of the story. What we're finding is that the story of pulses is likely going to get better, especially in Canada. And the reason being is that we've known for quite some time that emissions from the majority of emissions that come from pulses for nitrous oxide don't come from fertilizers. They come from the actual decomposition of the root material and the straw on the surface of the soil. And farmers can't do anything about that. They're producing a crop. It's got to have straw. It's got to produce residues. But what we do know is that it's probably it's overestimated in terms of the nitrous oxide based on the models that we use to measure nitrous oxide across our country. But there's actually been a new report that is suggesting and is being published in terms of a proposal that those coefficients that we use for those residues should actually be lower. So basically what I'm trying to say is pulses are low in Canada in terms of carbon footprint, but they're actually going to be even lower because the emissions from those residues is going to be redacted and revised in the future based on this new methodology that's been published and proposed. I actually just had a call with the people who wrote this paper. They've been at this for a long time. And so Canada has a really good, strong methodology already for measuring these things, but they're always redacting and always revising, which is good from our perspective, because we're able to accurately tell our story better than most places in the world. And really the real reason why we dug into developing this life cycle assessment is that we're seeing this more and more, is that companies are conducting life cycle assessments of their products, and the transparency and the sophistication of data required for these life cycle assessments keeps going up. So there was an example the other day about from the New York Times where there's a challenge being showcased towards the plant-based industry in particular in terms of how transparent this data is and where is the data being sourced from. And this, I think, really is the life cycle assessment that we've developed is really an answer to that question in terms of, well, here's the most comprehensive data set that you can produce for a major component of these plant-based foods being peas or pea protein. And there's more to come with some research being conducted at the University of British Columbia on actual ingredients that are processed from pulses like pea protein and pea starches. So that's ongoing and there's more to come. So I just want to end up with this life cycle assessment. What we're seeing is that it's more than just carbon. Our summary report showcases all the comprehensive impacts that you would see in a traditional life cycle assessment. So things like fossil energy, water scarcity, and land occupation are all being covered within that report and then are reported on. So you can take a look at the website that we see below. So just to help wrap things up here, I just want to make sure everyone's aware that this is a 3-part mini series. So next week we have our second webinar focused on crafting sustainable food and focusing on the impacts that pulses can have on reformulated food products and how that can align with companies' corporate goals for sustainability. So tune in next week, come back, I'll be happy to speak to you again. But for now, I just want to thank everybody for participating. in the webinar today. I'm going to open it up for questions now, and a reminder, if you'd like to submit one, just type your question into the Q&A box. So I'm going to take a drink of water. Okay, so the first question I see here is, what does the future of pulse production look like in Canada? Are there plans to expand acreage? Well, I mean, as Pulse Canada, this is something that we're trying to grow markets and diversify our markets all the time, and that comes with the need to expand acres if we are successful. So there is actual room, although we're the second largest producer of pulses in the world, there's actually more room to grow production of pulses in Canada. So in the West and the East, there's areas of the country where we don't have a lot of pulses that are grown in rotation. And there's opportunities to expand. Faba bean actually is a really good example of a crop that if we are successful and get markets opened up and production systems advanced, there's a whole swath of the country in the West and the East that are very well suited for faba bean production, which is a legume that likes cool climate, but also likes a bit of a wetter climate than what we see for peas and lentils. So there's good potential there. Let's see if there's another question here that's going to come. All right. Well, I think I'd just like to thank everyone for your time. And we're kind of, I don't see any more questions here. So I think I just want to thank everyone for joining. I'm looking forward to seeing everybody next week. And yeah, it's been great giving this presentation to everybody. So thank you.